Well, hello and welcome to the Smells Like Money podcast. Join me, Suzanne Chin-Taylor, the DooDoo Diva, as I interview guests who are making an impact on how we manage and operate systems for conveying and treating wastewater. As a veteran of the wastewater, trenchless, and civil infrastructure industry, each week I'll be bringing you industry know-how from industry pros who know how. Join me each week as I speak with representatives of organizations that are utilizing disruptive or new technologies and methods, and executives who are excited to share how to be successful and sustainable in our vital industry. So whether you want to learn about the latest trends in technology, in treatment or trenchless, gain tips on training and retaining great talent, or simply how to be more efficient, productive, or profitable, this podcast is for you. Ready? Let's dive right in. Welcome, everybody, to this week's episode of the DooDoo Diva Smells Like Money podcast. Today, we are visiting with Cody Warner, who is the Director of Sales and Marketing of Deep Trekker. And so, Cody, welcome to the show. We're going to be talking about some really cool things today.
Thank you very much for having me on. Excited to be here.
Now, for those of you who may not be aware, Deep Trekker is the developer and manufacturer of very specialized CCTV camera technology and robotics. And they've really been known for a long time for underwater inspection applications. But what we wanted to talk about today, and Cody and I met before he came on the show, about understanding what's really helpful in regards to CCTV data inspection, the collection, the data. You know, there's a lot of talk about 3D modeling and about AI. And so I wanted him to do a little bit of a deep dive with us in terms of inspection, data collection, and analysis, and what is really beneficial. You know, you've got all these bells and whistles out there, but at the end of the day, is that really going to help you do your job better? Either as an inspection technologist, you know, a contractor doing it for a city, or for the city itself, or a city engineer that's using that data. And so with that, I'm opening the floor for this discussion with you. So Cody, take it away.
Yeah, I think it's a very important topic, and I think it's one that doesn't get talked about a lot because people really just go right to the technology and to the features, and you hear things and you see things about 3D and you think, okay, I want that. But really, I think it's important for anyone that's involved in this industry, like you said, contractor or city engineer, it's important to start with the end in mind. Let's figure out what is it that I need exactly to solve the problems that are ahead of me. It's my goal. Am I really trying to tackle an I&I problem, and I'm just really, my goal is to find where are the big problems? Then you don't need a 3D model of every pipe in order to achieve that. Am I trying to really systematically plan ahead for decades in advance and find where potential problems are going to be and make a really systematic plan for my rehab? Then 3D is a great direction to go. It's the best data that you can get. So it's really breaking down what's the end goal and problem for the customers.
Okay. So now, where do you see, you know, we talk about it's important that we're educated as to what's coming out as technology. What do you see as, you know, coming next on the horizon for CCTV inspection? What's going to be the next greatest tool in the toolbox?
Yeah, there's some great advancements in camera technology. So not just increasing the resolution, there's really, sewers were one of the last industries to see 4K cameras, but there's now a push towards being able to build models and get depth perception from stereo cameras. So I see the potential for either 360 cameras or stereo cameras being able to now give us bits of data live as we're going. So important decisions like measuring cracks, I don't necessarily need to have the full model of that section of pipe or a full length of pipe, but I just want to know what a particular feature is. That's where a simple and more advanced camera option is going to give you that data, as opposed to needing other sensors like laser LiDAR.
Well, explain, in case there's somebody listening that does not know the difference between this. I mean, you and I do, but what are those differences between what you just mentioned,
Yeah.
stereo, panoramic, and in comparison to what we have now, where we're doing, pan and tilt?
Yep. So your phone has a stereo camera. So you can see here, there's two cameras instead of one,
Okay.
or at least most cameras have them. So the two cameras instead of one is just like your eyes as well. It's your ability to now have to perceive depth. But with great, much more brilliant minds than myself, software engineers are able to take that information and give you that distance from a target. So that'll be able to be now take that, and if I know the distance to said start of the crack and to the end of the crack, then I'll be able to start doing measurements. And now it's about building an interface that a user can use and go and build that. This doesn't exist in this moment, but there are some great advancements coming in other areas of other industries. So an example would be aerial drones, and in underwater robotics are both making big advancements on this front. And sewer crawlers and sewer technology tends to just lag a couple years behind, and it'll catch up and be there too.
Well, since your company is one of the absolute leaders in underwater robotics and inspection, let's talk a little bit about that, and the applications for that, and also the opportunities for underwater inspection, and why is that so important for cities? And I'm just thinking those difficult lines that, because they're underwater, they really haven't been looked at.
Yeah.
They've been ignored,
Yeah.
and we can't ignore them for much longer. Well, we could, but it could wind up being a catastrophic problem if we continue to just kick that can down the road.
No, exactly. So typically in a sewer, you're not going to be sending a swimming ROV down it. It just doesn't make sense. The sensors and technology is not going to be able to give you a good picture. But there are a few great examples of areas where a robot is the best tool for the job and is unique compared to a crawler. Combined sewer and storm systems are a perfect example of this, where you tend to have a lot of flow, a lot of water, and combined sewer and storm may not be a common practice anymore, but they do exist in some of our biggest cities around the world. Great example is actually in Toronto, just up the road from us here. And we had a project with them and one of our customers where we went and explored a combined sewer and storm pipe that was 600 meters, or for our American listeners, well over 2,000 feet in length, and it went right under the busiest part of the city. And this pipe hadn't been explored in the 100 years that it existed. So we've no idea. We've got this critical artery going out into Lake Ontario, and no one has ever looked at. We have no idea what to expect. And the conditions we do know is that there's zero visibility. So you go into the water, you've got a camera there, there's no visual. We know that there's sediment at the bottom of this thing. So then okay, if I'm driving a crawler, it's going to just stir up all the sediment, and any sensor is going to be not useful, right? So now we were able to swim the ROV inside with an imaging sonar, and we were able to get a look and see the ovality of the pipe. We were able to see how much sediment is built up. We pressed the sonar against the surface of the pipe and painted a picture of the pipe walls. And now we're able to pick up details like cracks. We were able to find a crack in the pipe that was maybe about 7 inches long. And now we've got a target. So you go, okay, we know we are approximately 1,000 feet into this pipe. We're going to go back to that target in a year or 2 years, and let's see how that crack has progressed. Let's see, is it becoming a bigger issue, or is it just a feature of the pipe that we can ignore for a little while?
Okay. Let's talk about sonar for a little bit. It's been around for a while, but I don't hear much about it. And as you know, I interview a lot of folks, for articles. They talk about things like what you were talking about, but there's got to be some really, that was one you just cited. Should sonar be considered to be used more often than it has been? And if so, how should that be incorporated into the mix?
It's a great question, and it's a great technology for a very specific set of circumstances.
Okay.
If we're talking about a dry pipe or even a partially submerged pipe, the most accurate sensors are laser and are your cameras. Sonar is inherently a little less accurate because it's using acoustics. It's not going to be able to provide as good of quality of data. So when we talk about where's the future, people want the most accurate data possible. You want to be able to have really reliable data. But when you go underwater and there's suspended solids in your water and it's a difficult, challenging environment, sonar is the only option. And that's where it really should be used more. And really the cost and the size of sonars is coming down. So now we're seeing it where it's accessible for a more casual user, we'll call it, or less, rigorous user. Maybe you don't have to be a very large contractor to use it anymore. Now, if I have a few stormwater pipes that are fully submerged that I want to get an understanding of their condition, I can put the sonar technology to use and not, spend my entire budget.
Can sonar findings be tracked and input into, a PACP software for analysis, just like regular CCTV inspection footage?
At this point, there's not a direct translation to that. There is when you do multi-sensor type robots where you have multiple inputs that then give you that. But if I wanted to just out of the box take an existing sonar and put that into a PCP software, that does not exist right now.
Okay, so that would mean the operator would have to manually correlate based on the findings, but it could be done. We just have to manually sort of quote unquote translate it.
It just takes a little bit of extra effort, but it's possible.
Now, in thinking about it, there's so many assessments out there. Maybe you can give some insight on this. I've just been curious. The electrostatic scans. Not going to name the manufacturer, but there's a couple out there.
Of course.
So how does that work for measurement and assessment in regards, or I would say in contrast or comparison to these other things we've been talking about? And then if I would really love it if you could touch on laser, because I think all these tools is that we shouldn't be looking at tools as one size fits all, that look at how you can get the best picture of what's really going on in the system and what is the best thing to capture that data.
Yes, I'm really glad that you brought that up, and I am glad that you mentioned that these tools are not a one size fits all, because I couldn't have said it better myself. The electrostatic side of things, the number one marketing message is that it's a competitor to a CCTV vehicle. So rather than use a camera, I want to use this, but I look at them as very complementary systems. And electrostatic, really, what you're able to find very quickly is holes in a pipe, or areas where continuity in a pipe does not exist, because I'm sending this current down, and if there's a hole in it, I will very quickly know how far away it is and approximately how large it is. Now, the problem is that there's other reasons for there being holes other than just I&I classics like cracks or rooting.
Right.
There's also a large number of laterals and pipes that are supposed to be there. So you have a difficult time verifying, especially because we know that drawings, as-built drawings, are not, not often the most accurate thing to rely on. So you're getting data, but you're not 100% confident in it. So it is a great complement to the CCTV vehicle, where if I'm in a dark PVC pipe, it can be difficult to use a camera to find a crack. It can be difficult even for lasers to identify a very, very small crack that electrostatic sensors are going to be able to find. So it's all complementary, but you'd also mentioned lasers, and lasers can come in a variety of forms as well. And that's what makes it even more complicated, is that you have very expensive laser scanning systems that are using a continuously moving laser to scan around and pick up many, many data points. And then you're stitching those data points together into a model as you go. That's the preferred option, but that technology is still kind of out of reach of most small to medium-sized cities or smaller contractors. The other option is laser ring, and that's where I paint a laser ring around a pipe. So now I have a circle in my camera feed, and I can use programs like different PCP software programs that are popular, and I can use that circle and it'll stitch it by taking a series of photos together. The nice part of that is it's relatively cheap. The problem is that I have to now have a camera view that is able to see that circle. That's easy in a smaller diameter pipe, but in a larger diameter pipe, it's very difficult to have a camera that will see the entire size of the pipe. And a lasering also has to sit very far out in front of the camera. So now I'm putting this big long device into a pipe, which can be difficult. So there are options. It's just now, I think that the industry as a whole is at a inflection point technology wise. I think what we're going to see if we're having this conversation in 5 years from now, that there's going to be very easy, low cost sensors available to most people to be able to perform these inspections.
Well, I remember when those first, fisheye cameras came out, and the whole thing was, well, you just run the camera down the line and you don't have to stop. You just run it and then you can do your inspection back at the office.
Yep.
Was that really plausible? Was that really feasible? And because again, that's another one of those things. It was really cool.
Yep.
Are people utilizing this? And is it the time saver that they indicated that it would be?
So I think it's a mix. It's just like every other tool has good moments and bad moments. I think when the pipes are in good condition and it's a good lighting environment and it's a small diameter, then it's an excellent tool, but it's very expensive in comparison to using a standard CCTV camera. So if most of your work is small diameter, and then it can be a very, very reasonable option and efficient option to perform the inspection. The problem when you expand the diameter, if we get larger trunk line sewers and you're expanding that diameter, it makes it harder and harder for cameras to identify distinguishing features. And that's what the software uses to stitch things together or to make it into one continuous row. And I think that the biggest hurdle I've heard with that sort of technology is that what happens when I see something I wanted more detail on and I didn't get it in the first run. Now I'm returning back to the job site. I'm coming twice now. You've doubled my time invested, and you're not necessarily confident that that technology is going to work to get that extra detail this time. So now we're going back to traditional methods to capture that same data. So
what's your feeling on, this could be a loaded question, AI for data collection? I mean, there's a number of companies that are working on it, have it in the pipeline. One of them is a guy, I guess you would call a common friend and colleague, Asim Balaraf from Fluid Robotics. Yep. In that, I think tying it into PACP and the accuracy, from what I'm hearing, it's getting close. But what do you see? Do you see it's going to be coming soon, or it's still a ways off?
I think that it depends on what I'm using it for. If I am using it as a tool to assist my operators to capture moments in the inspections that they may have missed, so defects that I, as a human operator, may have missed when I was doing the inspection, I think it's a great technology that's already useful in its current form. If we want to try and rely on it as this will be the tool that replaces human operators, and you'll never look at another inspection again, you'll just have an automated report generated, then we're a ways away. And I think the big problem is how confident do you want to be in the inspection data that you've created? That's the big question you got to ask. And it's have you seen all the hype lately about ChatGPT, the AI chat robot?
Right.
So the problem with that program, it's incredible. It's creating these wonderful written statements based off of knowledge across a variety of areas. But the big problem is it'll give answers confidently. So the same problem is with sewer AI in general, is anything related to a pipe inspection is how confident am I in that data that's coming back? I'm going to have these defects coded for me, but do I need to go and watch the video again? Probably. Do I then need to go and correct little mistakes that are made throughout? Probably. And at that point, how much time am I saving? And in some cases, you're saving it, but in some cases, you're not.
In some cases, you're not. Well, what do you see as the future for data collection and technology? And then also just touching on what, your cameras do, that, the deep water inspection. Are there going to be opportunities for contractors to look at, I've been doing standard CCTV inspection, but maybe there is a revenue stream for me in doing these underwater inspections? Where do you see the opportunities are going to be in the industry for inspection?
For the first part about where I see the future of technology in general, I think that one of the most interesting processes that I think could have some legs and take over is processing data and performing inspection reporting at the office rather than in the field. It's the challenge has always been because the technology is not quite there to properly capture the data. And if you don't have an experienced operator in the field, then they're not going to go and look at the things that you want them to. So then you have that problem of double visits. But the advantage is that it's very difficult for contractors in cities right now to be finding good, strong, experienced sewer operators and to attract them and to keep them. So there's a huge turnover problem. Well, how do we solve that? I think technology can be a big piece of that and will be a motivating force for that. So there's a few ways that we could look at this problem. One is, how do we get the inspection data that's happening in the field to go back to a person at the office? You can either have it happening live, and the only way to have live is if you have some sort of wireless communication happening between them, or the post-process. The post-process is risky because of that double visit where, I didn't get the data I needed. But the challenge is not everyone's going to want to be spending all the money on wireless data. It would be, thousands and thousands of dollars spent to transfer that data back to the office. With the improvement of 5G and with the introduction of those types of transmission technologies, if we can get that access to more remote locations, then I picture that changes how the sewer industry works, how the sewer inspection industry works. And that if we can make the cost of that transfer of data reasonable and fast, then I think that the live operators are not the experts. You're able to retain more people at the office. You're going to have a lot more efficient process with your pipe inspection. So any technologies that support that, and I think AI and modeling are other technologies that help make that data more accessible and put less strain on the experienced operator. So that's the future from a technology standpoint. Now, as for the future for underwater robotics and expansion of revenue streams, I think that both cities and contractors can see benefit from having the underwater ROVs, because there are various structures that need inspections that are just adjacent to where the sewer pipe is, whether it's stormwater pipe or reservoirs or dam structures or water storage tanks. All of these structures are part of the same system. And if you've already got operators that can run a robotic vehicle of one kind, it's not a big leap to go and run another one. So if you already have the systems in place for getting these contracts, for meeting with the clients and for generating this data, really it's just a switch of what's the project and using your existing resources toward that.
So what's next, without giving away anything proprietary? Giving you guys a little plug here for being on the show. What should we be watching for that's going to be new and exciting coming out from Deep Trekker?
So we have our new pipe crawler lines coming up, and we're going to be launching a whole new crawler in the we're aiming for the wet show, but we gotta see how things go over the next month or so of testing. So there'll be a whole new crawler to watch out from us. And then on the swimming robot side, the exciting side, there's some very interesting 3D modeling technology coming soon. I won't give too much away, but Deep Checker always aims to do things as easy as possible, make the customer's life as easy as possible. So
Yeah, I've heard that. And so I want to thank you for being on the show today. And for those of you who are interested in learning more, Cody, if you would share your website address, please.
yes, please go to deepchecker.com and pipechecker.com.
And that is spelled TREKKER, not CK. So, and do look up Cody on LinkedIn. He welcomes connections. And again, thank you for being on the show, sharing your expertise. And I'll be watching for some of those things and seeing what's coming down the pipeline, no pun intended, from your firm. And thanks again for joining us on this week's episode of the DooDoo Diva Smells Like Money podcast. And until next time, keep it flowing. Thanks so much for joining me, the DooDoo Diva, on this week's episode of Smells Like Money. What stood out to you this week? Share your takeaways by leaving me a review. You can find out more about the new technologies, creating sustainable solutions, and insights on how to succeed in our vital industry by subscribing to the show. Whether you want to learn about the latest trends in wastewater infrastructure, treatment, or trenchless, you've got it all right here at Smells Like Money. If you're an industry expert and would like to be considered as a guest for the show, book a quick chat with me by visiting calendly.com/the2it group/B-A-podcast-guest, or simply click the link in the show notes below. Until next week, a big shout out to all my industry friends and those who will be. You are my superheroes. Thanks for tuning in, keeping it flowing, and we'll see you all next week.